So a very beautiful moment, dear students. Welcome to today's lesson. So today I want us to focus on something else from what we have been dealing with. Remember previously I've been talking about the concept of the definite and indefinite interval. In this case, we said that in the case of the definite, it's where you have been given the limit. Therefore, you need to substitute and get your answer as a given figure. But if it is indefinite, your answer is going to be the equation plus an arbitrary constant, which is C. Then for today, what else? We shift the gear, and now we come to the area under the curve. Remember, area under the curve, we had estimated it using the idea of the trapezium rule and the idea of the mid-ordinate rule. And we say those two techniques do not give the exact answer, but they just approximate. So they're going to be realizing an exam. The section B question is going to be joined. The three rules will be joined together, and then you're added 10 marks. So this is the final part that you're going to deal with, getting the exact area under the curve. So you can use the trapezium rule, you can use the mid-ordinate rule, and then you can compare by getting the exact area using the integration method. So that is going to be my focus today. So you as a learner, what are you supposed to be able to do? There are some specific objectives that I want you to be able to know. So the one objective is that you're supposed to relate integration notation with the sum of the area of the trapezia under the curve. So once you read that one, you will be in a position to be able to get the exact area. So the content is the same as what you're going to do with the area under the curve by integration. And then let's try to focus on some of the examples that are going to take us through, and then we see what you can be able to answer those questions. So in my example number 1, you're told that you find the exact area. You can see even the instruction is that you find the exact area enclosed by the curve. So the name of the curve is given. That is your example number 1. The name of the curve is given as the y is equals to x squared. Then that is our number 1. So that area of the curve is given by a curve. That is the curve. That is one thing. Then it is also enclosed by the x-axis, the line x-axis. Remember, the line x-axis is the one we refer to as the line y is equals to 0. Then again, the line x is equals to 2. X is equals to 2. And then finally, the line x is equals to 4. So that's the area that is going to be shielded by those 4 items. The curve, which is the name, the line y is equals to 0, the x is equals to 2, and then the x is equals to 4. And then you can see the way the examiner is telling you. The examiner is telling you, find the exact area. Because he knows, if he don't tell you that way, if he tell you maybe, when he tell you to approximate, then that way you go to the mid-ordinate or the trapezium rule. But again, he will be guiding you, telling you to approximate using the trapezium rule or the mid-ordinate. But now when he tells you to find the exact area, he will not tell you whether to use the integration. But the instruction should guide you so that you are in a position to be able to know that you are supposed to be able to use the integration method when the word exact area is mentioned. So this is the way the sketch is. That's the sketch the way it is. You can be able to see here. That is the curve that we are talking about. That is the y is equals to x squared. Then we have this line which is x is equals to 2 here. And then we have this line which is x is equals to 4. Then we have this line which is going to be x-axis. Another name is going to be y is equals to 0. So this is now going to be the shaded region. So because now we are finding the exact area, we are going to use our limit. The 2 is going to be our lower limit. Then the 4 is going to be our upper limit. And then this is going to be the function that we are going to integrate with respect to x, as shown in my slide here. So you can see what we are saying. So you're going to take your equation there. So you have the limit here. So the limit is from 2 to 4. And then your equation is what? X squared dx. So you're going to integrate this equation with respect to x, and in a normal way, or the technique that I have shown is that you add the power. So this one is going to be x squared plus 1 divided by the new power. So 2 plus 1. This one is going to give us x cubed over 3, which is going to be 1 over 3 x cubed. Now we put the limit. We have from 2 to 4. Remember, if there was no the limit, you could have added our c. So because the limits are there, we need to come back now with the correct answer. So which is going to be a figure. So what you're going to do, we substitute the limit starting with the upper limit, then we feed them to the equation. So this one is going to be 1/3. Then instead of x we put 4, and then that one is going to be 4 cubed. Then that one we shield, we subtract. That is going to be 1/3, or then our 2 cubed. And then again we shield. And this one is going to give us what? This one will give us 64/3, then minus. The other is going to be 8/3. At the end of the day, you get your answer as 18. 2/3 square unit. Square unit. That is the technique which I'm saying. That now this one is going to be the method that you're going to be using to approximate, be able to approximate the actual area or the exact area under the curve. So this one, we're not going to be approximating, but we're going to be finding the exact area. So that is now example number 1. What else we focus again on example number 2, so that we see the different techniques that are going to be tested when we are focusing on the concept of the integration. And in our number 2, that is example number 2, you can see the way the examiner is telling us again, that find the area of the region bounded by the curve. So we have the name of the curve. The equation is given by what? That is going to be x cubed minus 3x squared, then plus what? Then plus 2x. Then apart from that one being bounded, we have another line that is still shielding our line. That is going to be the x-axis. We have the x-axis. This x-axis is the one we are calling it line. Y is equals to 0. Because along that x-axis, the value of y is going to be equal to 0. Then from there we have the line. We have the line, x is equals to 1. Then finally, we have now the line, x is equals to 2. That is the information that is bounding our region. So in a nutshell, you can be able to sketch it so that you can be able to obtain the information which is going to be there. And then you can see, as you can see from my slide there, that's what you're talking about. So this is going to be a normal curve. So from here, we're going that way. So meaning that here we have two. We have the two sides of this curve. You can see you have the upper part, and then you have the lower part. But because of the information, line x is equals to 1, then line x is equals to 2, so that one is going to serve as our limit. So this is going to be 1, then this one is going to be 2. This is going out to be the x-axis is equal to the line. X-axis on y is equals to 0, then the name of the curve. So meaning the required region is not the first part, because the first part is not within the limit. So this one is going to be on the second part. Thereby you have the shaded region ranging from 1 to 2. So what you're going to do is that we take our equation, we integrate it with respect to x, and then we put the limit which you are given. Then we see what you're going to get. So we are good to go. So the limit is from where? It is from 1 to 2. And then integrate your function, x cubed minus 3x squared, then plus 2x. So when you're performing this integration, the technique is the same. The technique is the same. Whereby you add the power by 1, and then you divide by the new power. So when you do this one, when we focus on that, this one is going to give us what? It's going to be x power 4 over 4, then minus, it's going to be 3x cubed over 3, then this one is going to be 2x squared over 2. Then you put the limit is from 1 to 2. That is the technique that you are going to be using there. So when you use that one, you have to make sure that you simplify, as you can see here, by 3, 1, by 3, 1, by 2, 1, by 2, 1. At the end of the day, you're going to have x power 4 over 4, then minus x cubed, then plus x squared, and then you have the limit is from 1 to 2. So in that case, we need to be able to substitute those values again. So when you substitute those values, so this one is going to be given. We start with the upper limit, always. Remember, you don't avoid maybe starting with the lower limit. It is the upper limit substitution minus the lower limit substitution. And when you do that, this one is going to be 1 over 4, this 1 over 4, then minus 1 cubed, and then plus 1 squared. This one we shield, then now we subtract. So this one we are saying now it is not 2, this is 2, this is 2, this is 2. Then again we minus the lower limit, 1 to power 4 over 4 minus 1 cubed, then plus 1 squared. So from your calculator, when you press that one, we are getting, our first part is going to be, this one is giving us what? It's giving us 4 minus, and see 8 plus 4. And then here we are having minus, that is going to be 1 over 4, minus 1 plus 1. So at the end of the day, we have 4 plus 4, that is 8. 8 minus 8, that is 0. Then you have minus. This one is going to be 1 over 4 plus 1, that is 1. 1 over 4 minus 1, you get that is going to be 1 over 4. At the end of the day, it's going to be 0 minus 1 over 4, which is going to give us what? Negative 1 over 4 square units. But you understand, square units, you understand that there is no way area can be negative. There are some of the quantities that cannot take a negative value. One is the time. However, using Bolt is going to be the fastest man in the world. There's no way you can be able to split 100 meters with negative second. So in time, mostly will never take a negative value. Then again, the length. There's no way you can walk a distance, then you say you have walked a negative distance. But some of the value can take a negative value, is like a temperature there. So in this case, this negative is indicating something. You need to ignore it. And why are you going to ignore it? Because the area cannot take a negative value. So this negative, the only meaning of it, it is telling us the area under the curve that we are trying to find is below the x-axis. So meaning it is on the negative side of the y-axis. As this one where I'm saying my NB there. But the negative sign shows that the area is below the x-axis. That is only the information the negative sign is telling us. So we ignore it, we ignore the negative sign and give it as a positive. So the answer is supposed to be 1 over 4 square unit. So again, that one is going to be a hint when you are calculating in an exam. So if you leave it at negative here, or not be, you're going to be losing the final mark because you understand that the area will never take a negative value. So with those 2 examples, I'm done with the first part of the video. Let us meet on the second part of the video. Thank you.